Welcome back. In part 1, we looked at Boost and what it could do for us, comparing the right baselines, and system requirements for ECV. If you need to verify that Boost is configured properly, stop and watch part 1 now, then return to this video for troubleshooting tips. Let's get back to the demo, where we're going to see what happens if the network memory disk is too small. Here's the same demo again, but this time we'll transfer a 2 GB file. On Administration Disk Management, we can see slot ID 1, which is the network memory disk, is only 1 GB. Let's speed up time a bit for this first pass. On the second pass, notice how throughput hasn't improved, and the flows report shows the reduction percentage is very low. We need to increase the network memory disk to be larger than the expected workload. Let's shut down the ECV, set disk 1 to 70 GB, and boot up. We'll do a quick time travel again for the first pass, since we need to populate the disk with the data patterns. And for the second pass, we can see that the file transfer is now accelerated fully. It's important, therefore, to size your network memory storage to accommodate your expected usage. There's a report you can use at Monitoring, Application, Summary, which can help you understand your usage over time. In our example here, we can see that CIFS accounted for just under 5 GB over the last 24 hours. By the way, it's not possible to identify which ECV had insufficient storage, so you'd need to check the disk capacity on both appliances on each side of the tunnel if they're both ECV. When troubleshooting Boost performance, it's important to compare the right baselines. For example, if you've recently moved a server from a branch office to the data center, and the user now has 20 milliseconds additional latency to their network drives, it is possible they may report slower performance than they were used to. For your troubleshooting step, it is important to compare the boosted flow's performance to an unboosted flow's performance to the same remote destination. Comparing a boosted flow to the previous local LAN performance is always going to be slightly worse to some degree, depending on the latency to the now remote server. You can easily do this comparison using temporary optimization policy rules to disable and enable Boost for a specific source host IP and prove that Boost is providing benefit. If you have an ECV at one end of the tunnel with symptoms of poor data reduction, and you've confirmed the payload isn't encrypted, check that you have enough disk space allocated to the network memory virtual disk for the expected daily workload. You can easily increase the disk space and reboot the ECV to resolve. This issue is rarely a problem on our hardware models, as they already have enough storage space available for most situations. Despite the amazing benefits that Boost can provide, it's still subject to the laws of physics. As round-trip time and/or uncorrected loss increases, the maximum throughput Boost can offer may diminish. So comparing the performance of a low-latency tunnel with that of one going halfway around the world is undoubtedly going to be different. Remember to compare a boosted flow with a baseline unboosted flow across the same tunnel. Also remember that encrypted payloads cannot be deduplicated or compressed, so these will never benefit from Boost. The exception here is SAS, or any SSL flow, where you have installed the server certificate onto your EC appliances, allowing it to decrypt the payload. When troubleshooting flows performance, remember to start with the Monitoring Flows report. Start by looking at the overall picture. The top consuming flows for the last 5 minutes are shown by default, and you can see their data reduction in this column. If they are all showing low values, there may be a systemic issue, such as insufficient Boost. More on that later. If only one is showing low values, you can dig deeper with the Detail button to see how it was handled. Here we can see our demo flow using SMB2, and can confirm it was using the default overlay, which has Boost enabled. The Optimization tab shows us that Boost was enabled and applied network memory and compression. If you found that Boost was disabled, you can then check your config deployment settings and your BIO settings for the overlay that was used for the flow. You may see some notes like remote appliance dropped out of Excel and no remote appliance detected. This means that the appliance at the other end of the tunnel isn't configured for Boost. Usually there is no Boost bandwidth allocated to it. This won't stop the flow from working though, just that not all of the possible Boost features could be applied to it. You may also see them if the remote appliance has started bypassing Boost due to oversubscription of the bandwidth allocated. And on that point, there is a report you can check at Monitoring Boost Summary on your orchestrator. Here it will report periods where there was insufficient Boost bandwidth available, represented in percentage and absolute terms. Percent time insufficient Boost is the percentage of each 1 minute sampling interval that the allocated Boost bandwidth was deemed insufficient. Minutes insufficient Boost is the amount of time in minutes that Boost bandwidth was deemed insufficient. This report gives you an indication of both possible performance bottlenecks due to the current Boost bandwidth configuration on this appliance, and also how well matched your configured bandwidth is to the workloads. You can view this by clicking on the Trends icon on the right to see it graphed over time. Boost licensing is applied in the outgoing direction, so you can see here that our client-side appliance, B1, is only reporting a tiny amount of bandwidth consumed since all file transfers were inbound to it. The server-side appliance, DC, shows the periods of time where the full 10 megabits per second to B1 were being utilized, but since it has 100 megabits per second of Boost bandwidth applied, it had more than enough available. We have much more information on Boost by clicking on the Help icon. I hope this has given you an insight into how Boost works, and some basic troubleshooting tips to help you get the best from your SD-WAN. That's all for this video. Thanks for watching.